Hello, I'm Woo-Chan Kim, a second semester master student at PRM Lab at Korea University. Now, I'll present the second project of the Advanced Big Data Analysis course. For this project, I developed a classifier that distinguishes between AI-generated images and real images. The goal of this project is to develop a deep learning model that effectively distinguishes between real and AI-generated images. This kind of model can help prevent the misuse of generative models by detecting fake content before it spreads. I choose this topic because the growing use of generative AI has led to a surge in fake news and malicious synthetic images which can cause social confusion and distrust. This is closely related to my previous project proposal on fake news detection, and I thought that expanding the research to visual misinformation could be even more impactful, since fake images can spread faster and more destructively than fake text. The dataset used in this project consists of 4,000 images in total, 2,000 real photos and 2,000 AI-generated images. I used 80% of the data for training and the remaining 20% for validation. According to the initial project proposal, the classification model was based on a pre-trained ResNet 18 with ADAM optimizer and cross-entropy loss. And also data augmentation techniques was used to make more data for training by using image resizing and random horizontal flip. And lastly, the proposal reported a final validation accuracy of 83.75%. However, when I analyzed the original code, I noticed that the random seed was not fixed, which caused inconsistent result every time the code was run. To address this, I set a fixed seed to ensure reproducibility. With the fixed seed, I was able to achieve a validation accuracy of 98.25%, which was higher than the result reported in proposal. After running the original code, I searched several limitations in it to improve the performance by fixing the limitations. And I particularly focused on the compatibility of the original model architecture because ResNet 18 used as the backbone model of previous project is very outdated model. And then I found three limitations of ResNet 18 when it is used in the project. First, although ResNet 18 is relatively lightweight among ResNet variants, it still has more parameters than recent efficient architectures like EfficientNet, which can lead to overfitting when trained on small datasets. Second, ResNet lacks channel-wise attention mechanisms, treating all features equally, making it harder to capture the subtle difference between real and fake images. Third, ResNet mainly scales in depth, which limits its efficiency compared to modern models that apply balanced compound scaling strategies. To address these issues, I replaced ResNet with EfficientNet, which could solve these limitations. First, EfficientNet is a lightweight yet highly effective architecture. It significantly reduced the number of parameters and computational cost while maintaining high accuracy. This makes it well suited for small datasets and helps reduce overfitting. Second, it incorporates squeeze and excitation blocks, enabling channel-wise attention. This helps the model focus on the most informative features, improving its ability to distinguish real from fake images. Third, EfficientNet adopts compound scaling, which jointly scales the model depth, width, and input resolution in a balanced way, resulting in more efficient and scalable learning. Next, I will present the result of my experiments. In this study, I compared the performance of my proposal model, EfficientNet, not only with the existing baseline model, but also with another benchmark model, DenseNet. It's shown in the result, EfficientNet outperformed both of the other models by significant margin. Furthermore, the accuracy on the training sets and the validation sets showed minimal difference, indicating that the model effectively avoided overfitting. The highest performance was achieved at 9th epoch with an accuracy of 99.62%. From the 10th epoch onward, a noticeable gap between training and validation performance emerged, signaling the onset of overfitting. This result highlights the importance of selecting appropriate model based on the datasets and tasks at hand. This project clearly demonstrates how crucial model selection is for achieving optimal performance. That concludes my presentation. If you have any question, feel free to contact me via email, and you can see the course through this GitHub. Thank you.